Okay, so I accidentally didn't realize this, but I had worked this problem out. I thought I was recording and I wasn't, so I'm going to go through this again. I want to get the equation of a tangent line to the function at a given point, and they give me this point. So in order to get the tangent line, I need not only the point but the slope, so the derivative is the slope, and I've got to get, I'm filming, so the derivative of x is 1, the derivative of this is going to be negative 4x, and then I want to get when that x is 1, so I plug that 1 in for this x, and I get that the slope at 1 is negative 3, and then I take y minus negative 1, I get negative 1 from here, and then I get my slope of negative 3 here, and I get x minus that x value there is 1, and that's the equation of my tangent line. The difference in this problem is they only give me the x value, so I have to plug that x value into this function, and when I get that, I get a y value of 2, so the point I'm going to use on this one is 1, 2. And then I change this function into a rational exponent by changing it from a radical into a rational exponent like we did yesterday. And now I can do my derivative, so I take a half times 2 and get 1, and I subtract 1 from a half and get negative a half, make that a positive, and I put it back in radical form. Now I want the slope of this when my x is 1. There's nothing there. So I plug 1 into this derivative, and this will give me my slope. So the slope of this function is 1. So once again, I do my point slope formula. So I take y minus that 2 is going to equal this slope m times x minus that x1, which is 1, and there's that tangent line. Okay, horizontal tangent lines mean that the slope is 0. A horizontal line has a slope of 0, which means the derivative needs to be 0. So I find the derivative of this function by taking 2 in front and get 2x. Derivative of 4x is 4, and this is 0, so I'll leave it off. And now I want to find when this is the slope, and I want to find the slope when the slope equals 0. So I set this slope equal to 0. I do algebra. And I know that this slope is going to be 0 at x equals negative 2. So now I need to find the point, because it says point, not just x value. So I'm going to plug negative 2 in up here for these x's, which I did right here. And I solve this and get negative 5. So that means that the point negative 2, negative 5 is where this function would have a horizontal tangent line. This is going to be real important later. Ensuring there's a tangent to a given line, so we got this function, and this is supposed to be the tangent line, and we got to find a value of k that will make this the tangent line to this function. So I've told you a few times in class, there are two things between a tangent line and a function that are the same. One is the point of tangency. The other one is the slope of the function is the same as the slope of the tangent line. Well, this slope of this tangent line is 6, because that's y equals mx plus b. And to get the slope of this function, I have to do the derivative. So I take 3 in front, lower the power, then I take 1 times k and get k, and lower the power. So this is the derivative, which is also the slope. So this has to equal 6, so I get one equation right here with 2 variables. Again, the other thing that's true is the point of tangency is on this equation and on this equation. So this is y. 6x minus 2 is this y, and this is the y that's the same y value for the point of tangency. So I can take this thing, which equals this y, and set it equal to that y, because the y value here has to be the same as the y value there at the point of tangency. Okay, so now I have this equation and this equation. It's got 2 variables. There's an x and a k in this one, and an x and a k in this one. So I take this equation and I solved it for k by subtracting 3x squared over. Then I take this 3x squared and I plug it in for that k, and now I'm going to solve this equation right here for x. So I distribute this x and I get x cubed plus 6x minus 3x cubed equals that 6x minus 2x. I can subtract 6x from both sides, and those cancel. X cubed minus 3x cubed gives me negative 2x cubed. I divide each side by negative 2 and cube root, and I get x is 1. Then I can take that 1 back over here and plug it in for that x, and when I solve this, that means k equals 3. So the value that gives me a point of tangency with that tangent line is when k is 3. So if that's 3, this would be the tangent line of that function. And that would happen when x is 1. And I could find a point by plugging 1 back in for these two with that 3, but it doesn't ask for that. It just wanted me to find k. So I hope you have a good day, and I will see you tomorrow.